Hi, this is Michael of MCM Design. I'm recording a new video series which will report the progress of the construction of my final modified for high-res Astrocade. This Astrocade will include most of the features of my previous two high-res Astrocades, plus have some new features. This new project was announced a while ago. The announcement is archived on the Bally website. I thought it would be appropriate to begin this video series showing an overview of this final high-res Astrocade, which is what you're looking at right now. On the left is an illustration of the boards that will make up this Astrocade. Board 1 will not be connected to the motherboard's 50-pin expansion. This will allow board 1 to be removed from the add-under console and placed in front of the motherboard on a table for an easier troubleshooting experience should a failure occur on one of these two boards in the future. The multi-pager hardware will be relocated from board 1 to board 2 since only 3 wires are needed to select one of 8 screen RAM pages. These 3 wires plus a few more wires from the graphics mode software select scheme will be routed to board 1 using a mini ribbon cable connection. This relocation eliminates the need for board 1 to be connected to the motherboard's 50-pin expansion. Note the add-under console will have a horizontal rack for boards 2, 3, and 4. Of particular interest to me are 2 new added features, a pattern transfer board and a wiring modification of the cassette cartridge interface. Not tested yet, I am hoping my new CCI idea will allow programmed videocades to run at 2002 3 FFF hex up to 8 KB or 8002 FFFF hex up to 32 KB. This new modified for high-res Astrocade is going to be awesome. At this time, I would like to inform you of an error in the Bally motherboard schematic. This schematic is included in the Bally Service Manual PA-1, which is posted on the Bally website. I have the service manual right here. Bally Service Manual PA-1. The error is located between the custom address and data chips. Right here. I have the correction. Top circuit shows what's on the schematic. Here's the correction. Pin 4 of U6 is wired to pin 9 of U20 and also one end of the R38 resistor, which could be 47 or 100 ohms. The other end of that resistor is wired to pin 1 of U6 and also the PX line. This is an overview of the required motherboard modifications needed to run the low and high-res static screen RAM that will be on board 1. This drawing 1 is posted on the Bally website in the devoted section documenting the MCM Design modified for high-res Astrocades. This is the top view of the motherboard I chose to modify for high-res. I chose this board because only 2 chips are not in sockets. In this project, I am initially going to keep the motherboard modification to a minimum. Now I'm going to take a close look at these modifications. This clip covers 2 motherboard modifications. In the upper right is a modification that may not be necessary. For now, I desoldered and raised up one end of the R14 62 ohm resistor. This is the end that is wired to the 7 MHz clock area. I disconnected this resistor because the R14 C18 circuit was not part of the Datamax UV-1 scheme. I can later resolder this resistor to see if it will create a performance issue. The R14 resistor end is desoldered and raised up right here. The other modification is necessary. The custom data chips pins 11 and 12 must be disconnected from ground. These two pins are the serial 0 and 1 input lines used for the high-res video display scan. This particular data chip has some heatsink glue spillover on top of pins 9 and 10. Pin 12 is connected to a ground trace. You can use a utility knife with a sharp tip to cut the ground trace or gouge it open. Pins 11 and 12 are connected together on the bottom of the motherboard. The trace connecting pins 11 and 12 must be cut open. You can use an ohmmeter to confirm pins 11 and 12 are disconnected from ground and also each other. The data chip pin 12 ground trace is gouged out right here. A major modification is that all 8 RAM chips plus the U23 chip must be desoldered and removed from the motherboard. Fortunately for me, these 9 chips were in sockets, making the removal easy. Nice. I also inserted a 1200 ohm resistor into the U30 socket to help discharge the plus 12 volt supply when the power is turned off. Another modification was to desolder one end of each of the 6 1K ohm pull-up resistors wired to the RAM address lines A0 to A5, which are on the output of the U20 chip. This clip shows one of those 6 pull-up resistors desoldered and raised up. The 1K pull-up resistor wired to the RAM address line A3 is desoldered at that A3 connection and raised up here. A little hard to see. The 27 ohm power resistor R1 must be moved to the left to provide room for the 28 pin ribbon cable socket that is used to supply 28 signal lines to the screen RAM board 1. The R1 resistor on this motherboard has a piggyback resistor on it. The R1 resistor must be desoldered and rotated 180 degrees. A hole must be drilled on the left so the unsoldered end can be fed to the bottom of the motherboard for a connection to the voltage regulator VR2 input terminal. I scraped away some of the R1 motherboard trace, drilled 2 holes and mounted a 28 pin machine tooled wire wrap socket with its wrapping posts snipped down to about 1/8 of an inch. Note there is a non-metallic washer below the hex nuts visible here. You can also see the remaining 5 1K ohm pull-up resistors desoldered at the RAM address lines and then raised up at the loose ends. The 6 1K ohm pull-up resistors are not shown on the Bally schematic or components layout drawings. These 6 resistors are not needed for the screen RAM scheme on board 1, and I have observed, if not disconnected, they will shorten the usable range on the Razline adjustable trimmer resistor. For now, I'm leaving the plus 5V end of each pull-up resistor soldered in place. You can also see 3 yellow number 30 wires connected like this. Socket pin 21 to line A4, socket pin 22 to line A0, socket pin 23 to line A2. The 5 pull-up resistors shown here are connected to the RAM address lines like this. Address line A2, A0, A4, A5, and finally A1. This is a modification that may not be required. The RAD0 line at the custom address chip pin 9 is wired to the screen RAM board 1. This same RAD0 line is wired on the motherboard to U21 pin 12, so I cut the trace near pin 12. I made the cut because I'm not sure this extra load on the RAD0 line would create a performance issue. I'm also not sure if this RAD0 output can drive 2 TTL inputs. This is the final modification viewable on the top of the motherboard. I desoldered the end of the R38 resistor connected to the PX line. R38 is 100 ohms on this motherboard. The PX timing might be affected if I leave the R38 C54 and U6 inverter connected. I can later resolder this end of R38 to see if it will create a PX timing performance issue. This is an overview of all the modifications visible on the bottom of the motherboard. The 6 visible modifications are a 28-pin wire wrap socket mounted to the motherboard bottom, screen RAM address lines A1, A3, and A5 tap and wired to the ribbon cable socket, a double wrapped wire connected from the R1 end protruding through the bottom of the motherboard to the voltage regulator VR2 input terminal, a ground wire added to connect to the screen RAM board 1, cut open the trace at custom data chip connecting pins 11 and 12, tap and wire an additional 22 signal lines to the ribbon cable socket. Let's look at the modifications on the bottom of the motherboard. I chose to mount the more rugged machine-tooled wire wrap socket. The downside of this choice is the socket has no mounting provision. So I cut down to size a hobby board pre-punched for wire wrap sockets, drilled 2 holes in the hobby board to line up with the 2 holes on the motherboard, and fastened the socket to the board by twisting together 2 number 24 gauge bus wires around the socket and hobby board. The wrapping posts were cut down to about 1/8 of an inch long using a wire cutter. I used 2 number 3-48 size 3/4 inch long screws with 3 hex nuts per screw. 1 hex nut used to fasten the hobby board to the screw, and the other 2 hex nuts to adjust the socket distance from the motherboard. A non-metallic washer was used on the motherboard top. This socket mounting is rock solid. There are 3 yellow socket wires soldered to the RAM address lines A5, A1, and A3. Here are the 3 socket wires soldered to the RAM address lines at these points: A5, A1, and A3. The R1 resistor end protrudes into the bottom of the motherboard and has double wrapped blue wires soldered to it. Here's the double wrapped blue wire soldered to the end of the R1 resistor protruding through the bottom of the motherboard. There is also a motherboard ground wire for the screen RAM board 1. Here's the ground wire soldered here. The end of that ground wire is connected to the screen RAM board 1. Here's a closer look at 3 modifications on the bottom of the motherboard. The protruding end of the power resistor R1 is connected to the voltage regulator VR2 input terminal using a blue double wrap of number 30 wrapping wire. Here's the connection from the end of the resistor to the VR2 input terminal. There are 22 motherboard signal line taps wired to the ribbon cable socket. Here are the tap locations. You can refer to the Drawing 1 schematic previously shown in this video. One green wire for the data enable line connected to U23 pin 1. Here's the green wire, U23 pin 1. One yellow wire for the PX line connected to U20 pin 9. Here's the yellow wire, U20 pin 9. 8 blue wires for the custom data MD0 to MD7 lines connected at each RAM chip pattern data input pin number 2. 8 wires here connected to the pattern, the RAM pattern pin 2. 2 yellow wires for the Z80 address A0 and A1 lines connected at the RAM pins 8 and 7. 2 yellow wires connected to RAM pins 8 and 7. Two red wires for the serial 0 and 1 lines at the custom data chip pins 11 and 12. Here's 2 red wires to the custom data chip pins 11 and 12. The trace between these 2 pins must be cut open. You can't see it, but I use the utility knife and slit the trace between these 2 pins. 4 red wires for the custom address RAS0 to RAS3 lines connected to U17 at the pins 9, 10, 11, and 12. The 4 RAS lines connected to the address chip pins 9, 10, 11, and 12. 1 red wire for the inverted 7 MHz line connected at U16 pin 6. Here's the red wire connected to U16 pin 6. 1 blue wire for the 7 MHz connected at U16 pin 5. Here's the blue wire, a little hard to see, connected to U16 pin 5. One white wire for the inverted 1.78 MHz not connected to U15 pin 13, but the other end of the R18 150 ohm resistor. Here's that white wire connection. It is not connected to U15 pin 13, but the other end of that 150 ohm resistor. And finally, 1 green wire for the 1.78 MHz clock, not connected to U15 pin 10, but the other end of the R15 47 ohm resistor. Here's that green wire connection, not connected like I said to U15 pin 10, but on the other side of that 47 ohm resistor. That's it for detailing the Astrocade motherboard's modifications for my final high-res Astrocade. The next progress report should be more interesting. What you are looking at now is MCM Design Schematic showing all those capacitors around the 8 RAM chips on the Astrocade motherboard, which help pass to ground some undesirable power supply transients instead of being passed into the chip's internal circuitry.